Hi everyone, this is Kantraju HD, Assistant Professor in Mathematics, Government First Grade College for Women, Kerala. This video is made for SEC Math 02 Numerical Analysis prescribed by University of Mysore. So, in this session, I am going to explain numerical analysis. Under that, interpolation with unequal intervals by Lagrange's interpolation, and under that we are doing some problem. Lagrange's interpolation formula. Let f of x naught, f of x1, f of x2, f of xn be the n plus 1th values of the function y is equal to f of x corresponding to the arguments x0, x1, x2 and so on xn, not necessarily equally spaced, because when we apply a Newton interpolation formula, the argument should be equally spaced. While we applying Lagrange's interpolation formula, the arguments need not be equally spaced. This is the very important advantage of the Lagrange's interpolation formula. The interpolation formula is like this: f of x is equals to x minus x1 into x minus x2 into and so on x minus xn in numerator, all divided by x naught minus x1 into x naught minus x2 and so on x naught minus xn into function value at x naught, plus x minus x naught, x minus x2 and so on x minus xn, all divided by x1 minus x naught into x1 minus x2 into and so on x1 minus xn into function value at x1, that is f of x1, plus and so on x minus x naught, x minus x1 and so on x minus xn minus 1, all divided by xn minus x naught, xn minus x1 and so on xn minus xn minus 1 into functional value at xn, that is f of xn. This is the interpolation formula given by great mathematician Lagrange's remark. That means here we have to note that above formula is used for when data is for both equal and unequal intervals. So Lagrange formula we can use it for both equally spaced arguments as well as unequally spaced arguments when the number of entries are small. So while we apply the Lagrange's interpolation formula, the value should be very small. If the values are very large, the calculation is little difficult. This formula is used to find the polynomial for the given distribution. So this formula is also used to find the extrapolation. Let's see one example. Estimate f of 6 from the table. Table is like this: x 3, 7, 9, 10. Corresponding functional value y is equal to 168, 120, 72 and 63. Observe the value of argument, that is value of x 3, 7, 9, 10. They are not equally spaced. Let's see solution. In this problem, this is the value of x, this is x naught, x1, x2 and 10 is the x3. 168 is f of x0, 120 is f of x1 and 72 is f of x2 and 63 is f of x3. Substitute these values in Lagrange's interpolation formula. We get f of 6 is equals to 6 minus 7 into 6 minus 9, 6 minus 10 all divided by 3 minus 7 into 3 minus 9 into 3 minus 10 into f of x0 value 168 plus 6 minus 3 into 6 minus 9 into 6 minus 10 all divided by 7 minus 3 into 7 minus 9 into 7 minus 10 into 120, that is the value of f of x1 plus 6 minus 3 into 6 minus 7 into 6 minus 10 all divided by 9 minus 3 into 9 minus 7 into 9 minus 10 into f of x2, that is 72 plus 6 minus 3 into 6 minus 7 into 6 minus 9 all divided by 10 minus 3 into 10 minus 7 into 10 minus 9 into f of x3, that is 63. On simplify this value, we get f of 6 as a 147. Let's see another example. That is, given table x is 0, 1, 2, 5. Corresponding function values are minus 10, 4, 12, 120. Then find the f of x. That means we have to find the polynomial in terms of x. Solution. Substitute the corresponding values x0. Substitute the values x0, x1, x2, x3 and corresponding functional values in Lagrange's formula. We get f of x is equals to x minus 1 into x minus 2 into x minus 5 all divided by 0 minus 1 into 0 minus 2 into 0 minus 5 into minus 10 plus x minus 0 into x minus 2 into x minus 5 all divided by 1 minus 0 into 1 minus 2 into 1 minus 5 into functional value f of x1, that is the functional value f of x1, that is 4 plus x minus 0 into x minus 1 into x minus 5 all divided by 2 minus 0 into 2 minus 1 into 2 minus 5 into 12 plus x minus 0 into x minus 1 into x minus 2 all divided by 5 minus 0 into 5 minus 1 into 5 minus 2 into functional value f of x3 is equals to 120. On simplification, we get x cube minus 8x square plus 17x minus 10 as from the second term we get x cube minus 7x square plus 10x plus x cube minus 6x square plus 5x into minus 2 from third term plus x cube minus 3x square plus 2x into 2 from the last term. On complete simplification, we have the function, that is f of x is equal to 2x cube minus 9x square plus 21x minus 10. Let's see one more example solved using Lagrange's interpolation formula. That is, by mean of Lagrange's formula, prove that y1 equals y3 minus 0.3 into y5 minus y minus 3 plus 0.2 into y minus 3 minus y minus 5. Let's see the solution for this problem. Let consider a table. The argument values are minus 5, minus 3, 3 and 5, corresponding our functional value as a y minus 5, y minus 3, y3 and y5. So, by applying the Lagrange's interpolation formula, we get y of x is equals to x plus 3 into x minus 5, x plus 3 into x minus 3 into x minus 5 whole divided by minus 5 plus 3 into minus 5 minus 3 into minus 5 minus 5 into y sub y of minus 5 plus x plus 5 into x minus 3 into x minus 5 whole divided by minus 3 plus 5 into minus 3 minus 3 into minus 3 minus 5 into y minus 3 plus x plus 5 into x plus 3 into x minus 5 whole divided by 3 plus 5 into 3 plus 3 into 3 minus 5 into y3 plus x plus 3 into x minus 3 into x plus 5 whole divided by 5 plus 3 into 5 minus 3 into 5 plus 5 into y5. Put x is equal to 1 in above Lagrange's formula. We get y1 is equals to 4 into minus 2 into minus 4 whole divided by minus 2 into minus 8 into minus 10 of y minus 5 plus 6 into minus 2 into minus 4 whole divided by 2 into minus 5 minus 6 into minus 8 into y minus 3 plus 6 into 4 into minus 4 whole divided by 8 into 6 into minus 2 into y3 plus 6 into 4 into minus 2 whole divided by 10 into 8 into 2 into y5. On complete simplification, we get the required answer, that is y1 is equals to y3 minus 0.3 into y5 minus y3 plus 0.2 into y3 minus y minus 5. This completes the solution. Thank you for watching.